In this video, I will introduce a paper about ground reaction force parameters during power snatch. Then this is a power snatch movement. And then this graph is showing ground reaction force and whole body power. Here, black line is VGRF, which stands for vertical ground reaction force. The yellow line is whole body power, and then the green line is HGRF, which represent horizontal ground reaction force. But before I talk about the paper, I'd like to share a research question that I had for this study. The power snatch is often treated as a vertical movement. So vertical components have been primarily analyzed in previous studies. However, based on the power snatch movement, the power snatch is not pure vertical movement, in that horizontal movement is also observed. Here is my research question. Does the horizontal movement significantly affect power generation during the power snatch? So I did this study to answer this question. The title of this paper is Determining the Best Combination of the Ground Reaction Force Parameters for Maximizing Power during the Power Snatch. Let me define the power snatch first. What is the power snatch? Then this is the continuous motion of a power snatch. So barbell is lifted from the floor to receive it overhead with the knee and the hips slightly flexed. And this is one of the most frequently used variations of the snatch for weightlifters. The power snatch is often treated as a vertical movement. So vertical components have been primarily analyzed in previous studies. For example, instantaneous peak vertical ground reaction force, VGRF, and rate of vertical force development, VFD, have been primarily analyzed as key parameters in previous snatch and power snatch studies. And the studies indicated that VGRF and VFD significantly affected the power production during the power snatch and the snatch. But the power snatch is not a pure vertical movement. Horizontal movement is also observed in the horizontal direction of the lifters. Let me show you both the vertical and horizontal movements during the power snatch. And then this is a barbell trajectory. And then we have 5 events here. And then each event is corresponding with the same number on this barbell trajectory. And then horizontal axis represent horizontal displacement of the barbell trajectory. And then vertical axis represent the vertical displacement of the barbell trajectory. So as you can see here, you can see the horizontal movement as well as the vertical movement. From a biomechanical point of view, it is likely that the vertical movement is predominantly governed by the VGRF, which means vertical ground reaction force. And then the horizontal movement is mainly dictated by the HGRF, which means horizontal ground reaction force during the power snatch. Therefore, the HGRF parameters needed to be combined with the VGRF parameters for more insightful data analysis. The purpose of this study was to determine the best combination of the GRF parameters for maximizing power during the power snatch. To achieve this purpose, both the vertical and horizontal GRF parameters were analyzed in this study. Method: 10 skilled non-professional males volunteered to participate in this study. Then they had at least 3 years of power snatch experience, and then 4 trial conditions. And one item testing was performed 1 week prior to data collection. And 1 week later, they returned for actual data collection. And then 5 power snatch trials were collected with a 60% of one item. For experimental setting, so we used the Vicon real-time motion capture system, and then we used force plate as well. And then a total of 59 markers were placed on each participant's body, and we also used Quant3D-XP motion analysis software to pull out actual biomechanical variables. Data extraction. In this study, the combined ground reaction force and then whole body center mass velocity were used as primary data. This slide is showing how we extract the data. VGRF, which means instantaneous peak vertical ground reaction force. So circle here. So we picked this point as the VGRF. And then HGRF, which means instantaneous peak horizontal ground reaction force. So square here. So we picked this point as HGRF. And then VFD, the rate of vertical force development, the solid red line here. So this slope was used as the VFD. And then HFD, which means rate of horizontal force development, the dotted red line. So we used this slope as HFD. And then PW means power. So here yellow line is a power graph. So we picked this point X as a power. We also extracted horizontal center of pressure. Then here this line represents center of pressure trajectory. So that this is a medial lateral center of pressure displacement, which means left-right direction. And then this vertical axis means anterior-posterior center of pressure displacement, forward backward movement. That's why we used this horizontal center of pressure as one of the data. For statistical analysis, the multiple regression analysis was used to determine the best combination of GRF parameters maximizing power during the power snatch. So independent variables were VGRF, HGRF, VFD, and HFD, and HCOP. And dependent variable was the power that we used SPSS, and the significant level was set at 0.05. Multiple regression result. So in this table, we can use the model 3 as it shows the highest R-square value here. So based on this model 3, so VGRF, okay, right here, and VFD and the HCOP were identified as significant predictors of power. In other words, increased VGRF and decreased VFD and HCOP would increase power during the power snatch. Okay, whole body center mass velocity results. Okay, let me explain this graph first. Okay, there are two lines here, and black line represents the vertical velocity, the VV, the vertical velocity, and the yellow line represents horizontal velocity, the VH. Okay, and then here we have three events here. TR1. TR represents transition. Okay, the TR1 is an instant when the vertical velocity goes down and horizontal velocity goes up. And TR2, okay, transition number 2, is an instant when the vertical velocity goes back up and horizontal velocity goes back down. And then V max is an instant when the vertical center mass velocity shows its highest value here. So as you can see here, the VH, horizontal velocity increased as vertical velocity decreased between TR1 and TR2. As you can see here, this vertical velocity decreased as horizontal velocity increased. And then horizontal velocity decreased as vertical velocity increased between TR to VX. Okay, discussion. So VGRF, which means instantaneous peak vertical ground reaction force. According to the regression result, the VGRF would increase power during the power snatch. And then this result was consistent with the previous studies showing the VGRF and peak power increase simultaneously. And VFD, the rate of vertical force development. According to the regression result, the decreased VFD would increase power during the power snatch. And then we used this formula to calculate the VFD. So VGRF max minus VGRF minimum, which means this point minus this point, and then divide this value by the time elapsed from here to here. Again, this slope was used as the VFD. So based on this formula, okay, there are three conditions that we can get the decreased the VFD. First, increased VGRF minimum, this value. So if you have increased VGRF minimum, it will allow us to have decreased VFD. And also, if you have increased time elapsed, this is right here. If you have increased time elapsed, it will also allow us to have a decreased the VFD. So lastly, if you have a decreased VGRF max value here, then it will also give us to have decreased the VFD. But as a faster vertical velocity and higher VGRF are always desirable during the second pull, it is necessary to increase minimum vertical GRF to decrease the VFD. Okay, this is again the center of mass vertical and horizontal velocity graphs. This is the vertical velocity, and then yellow line represents the horizontal velocity. Then we have a transition 1, 2, and Vmax events here. And then from here to here can be the first pull, and then from here to here can be the second pull. And then VGRF decreased during the first pull as the lifters vertically was slowing down. And then this deceleration is likely to prepare for maximizing the power during the power snatch. Despite the fact that the vertical deceleration was typical pattern observed during the first pull, okay, it would be inefficient as it would make it harder to rapidly reaccelerate during the second pull. HCOP, which means the horizontal center of pressure. For this discussion, you can just take a look at the yellow line, which is the horizontal velocity of center of mass. As you can see here, backward movement occurred in the beginning of the first pull, and forward movement occurred afterward. And then the forward movement continued until the middle of the second pull, and changed to the backward movement afterward. Increased HCOP during the first and second pulls was related to the increased horizontal barbell movement, which is undesirable movement during the weightlifting. Okay, center of mass velocity. So for this discussion, we need to take a look at both the vertical and the horizontal velocity. Okay, as I mentioned earlier, there are two transition events, TR1 and TR2. And then at TR1 right here, right? And then vertical velocity decelerated vertically, while the horizontal velocity accelerated forward. And then TR2, transition 2, the vertical velocity accelerated vertically, while the horizontal velocity decelerated forward. Okay? Therefore, it may be determined that both the vertical and horizontal movements occur simultaneously during the power snatch. And also, the phase between the TR1 and 2 may result from a counter movement prior to maximizing power. However, as an excessive forward movement would increase the vertical deceleration during the first pull, the forward movement needed to be minimized. In conclusion, practically so what? The vertical and horizontal movements occur simultaneously during the power snatch. Horizontal movement is inevitable as a counter movement before the second pull during the power snatch, but the horizontal movement needed to be minimized to reduce HCOP and then VFD for maximizing power. So again, here HCOP means horizontal center pressure, the VFD means the rate of vertical force development. Here are references that we used for this paper. Thank you for watching this video.